So today the student will be able to understand the parts of the exponential parent function and the effects of y equals a times b to the x power in order to identify their graphs. So today, first thing we're going to talk about is something called exponential growth. When things grow exponentially, it just means they grow super fast. So they'll start out kind of slow, but then very quickly they'll grow fast. A lot like the coronavirus did. So it started with a couple people had it, and then those people spread it, and those people spread it, and those people spread it. And all of a sudden you've got a graph that just spiked really high. So it's kind of fitting that we're talking about exponential functions. An exponential function has the x in the exponent spot. So the parent function is any function f of x equals b to the x power, where b is greater than 1. So we're not talking about b equals 1. We're not talking about b equals a negative number. It's just if b to the x power. Excuse me. So as long as b is greater than 1, then we have a parent function. So let's talk about just a couple of things about this graph. So I've taken b to the x power, and I've given you the graph that you would get from that. So it's going to look like this. Now, how did I come up with that? If I take random x values, so I picked -1, 0, and 1. If I plug those into the equation, b to the x power, so let's say b to the -1 power, I need you to think back to your rules of exponents and remember that if you have a negative exponent, that doesn't make any mathematical sense. So your negative exponent has to become positive, and you do that by creating a fraction and moving it to the other part of the fraction. So now I have 1 over b. b to the 0 power, anything to the 0 power is equal to the whole number 1. Then I have b to the first, which is just b, because b times itself 1 time. So that's how I ended up with these points. So you have when x is -1, b is 1 over, or the y value is 1 over b. When x is 0, the y value is 1. When x is 1, the y value will be b. Okay? Now, it's a little abstract right now because we just have letters, but when we put some numbers to it, it's going to make a lot more sense. When you're looking at this graph, the domain is going to run from -infinity to +infinity because it's going to go forever left and forever right. Okay? The range gets kind of funny. So the range is going to go from 0 to infinity, and it's never going to touch 0, so we use a parentheses, not a bracket. And I'll explain that a little bit more in a second. An asymptote is an imaginary line that your graph will never cross. This graph has an asymptote on the x-axis because the graph is going to get forever close to the x-axis, which is why we said 0, but it's never going to touch it. So we say we have an asymptote at x equals 0. There's a y-intercept we found at 0, 1. Okay, so now let's put some numbers to it, and it'll make a little bit more sense. So if I take the graph f of x equals 4 to the x power, we're going to build the graph of that equation, so we need to find some points that we can plot on it. So if I use x is -1, if I use x as -1, then I have 4 to the -1 power. Remember, if you raise something to a negative power, it doesn't make any sense, so you need to put it in the bottom of a fraction. So 4 to the first power is really 1/4. So I have an ordered pair, -1, 1/4. Okay? If x is 0, anything to the 0 power equals the whole number 1. So my next point is 0, 1. If x is 1, then 4 to the 1 is just 4. So I have an ordered pair of 1, 4. Okay? Now, I need you to see what happens when we go negative. So if I plot these points, I have -1, 1/4. That's somewhere around there. 0, 1. 1, 4. Okay, so my graph is rising very quickly. right? But I don't know what's really going on after the -1. So let's just kind of pick a couple more negative numbers to make sure we understand what's going on. So if I have 4 to the -2 power, that's really 1 over 4 squared, which is 1/16. So I have -2, 1/16. So at -2, I'm even smaller. Then 4 to the -3 power is 1 over 4 cubed. That's 1/64. So I have -3, 1/64, which is even smaller. So as we go to the left, as our graph moves left, we are getting closer and closer and closer and closer to 0. But we're never actually going to touch it. So it's really hard to draw that. But it's going to go really close to 0, but never actually be on that line. So we have an asymptote at x equals 0. Because it doesn't matter what negative number you pick, it's always going to be a fraction that's going to get you closer and closer and closer to 0. So that's where we come up with that asymptote. All right, the domain goes forever left and forever right. The range goes from the asymptote of 0. We'll never touch it, so we use a parentheses, to infinity because it's going to go forever high. The y-intercept happens where x is 0, and that was here, is at 1. All right? Okay, now we're going to start talking about transformations. So we're going to take our parent function b to the x power, where b is greater than 1, but we're going to multiply it to an a value. So I'm going to multiply this graph by some value. An a value vertically, so up and down, stretches or compresses the graph. So basically it's going to make it rise faster. Oops, I didn't mean to erase that. Rise fast or rise slow is what we're looking at so far. So think of it as it getting steeper or flatter. Okay, so the graph is going to look either steeper or flatter than if you just had the original b to the x power. Okay, now this part here that I had kind of sectioned off, we're going to come back to this after we complete the next two examples because it'll make more sense at that point. Okay, so if I have f of x equals 2 times 3 to the x power, then I'm still going to plug in my numbers to find my points. So if I have 2 times 3 to the -1st power, you cannot multiply until you take care of your power. So remember PEMDAS, you have to do the exponent first. So I really have 2 times 1 over 3, because remember a negative exponent makes it a fraction. 2 times 1/3 is 2/3. Okay, now to the 0 power, 2 times 3 to the 0 power. Anything to the 0 power is 1, so this is really 2 times 1. 2 times 1 is 2. The first power, so 2 times 3 to the first, is really just 2 times 3, so you get 6. So I have an ordered pair, -1, 2/3, 0, 2, 1, 6. So let's plot those. So -1, 2/3 is about here, 0, 2, and 1, 6. Your graphs are not going to be perfect today because you're sketching them by hand, so you just need to get them as close as you can, okay? All right, now, if I pick a couple more negative numbers just to see what's going on. If I pick -2, I've got 2 times 3 to the -2 power is 2 times 1 over 3 squared is 9, so 2/9. Okay, and then I have, if I pick -3, 2 times 3 to the -3, it's really 2 times 1 over 3 cubed, which is 27. So it's 2/27. So if you notice, the denominator keeps getting bigger, so my numbers are getting closer and closer to 0. So again, I have an asymptote at x equals 0. Okay, the domain, so my graph goes like this. It's getting closer and closer to the x-axis. The domain, though, goes forever left and forever right. The range goes from the asymptote 0 to infinity. And the y-intercept, okay, this is different. The y-intercept is not at 1 anymore. Now the y-intercept is at 2. So our y-intercept when x was 0 is at 2. Okay, I need you to notice that that is the same as the a value, okay? Up here, we didn't have an a value, so we're really multiplying by 1. So we could have said 1 times 4, or we could have said 1 times b. So that's why our y-intercept was at 1. So whatever your a value is, that's going to give you your y-intercept. Now, I also need you to notice this point at 1. At 1, we have 1, 6. So this point. So when x is 1, y is 6. Now that 6 came from a times b. So if you take your a value and your b value and multiply them together, you end up with your point at 1. Because when the exponent is 1, it doesn't really change anything. Just kind of keep that in mind. All right, the next example, y equals 1/2 times 2 to the x power. So if I'm using -1, then I have 1/2 times 2 to the -1. It's 1/2 times 2 to the -1 becomes 1/2. 1/2 times 1/2, 1/4. Okay? Then I have 1/2 times 2 to the 0 power. Anything to the 0 power is 1, so I have 1/2. Okay? 1/2 times 2 to the first power is 1/2 times 2, which is 2 over 2, which is 1 whole. All right, so if we plot those points, we've got -1, 1/4. We've got 0, 1/2, and 1, 1. So this one rises very slowly. It's not very steep at all. Again, if I picked further negative numbers, I would get closer to 0, but I wouldn't cross it. So my asymptote happens where x equals 0. My domain is everything to the left and everything to the right. My range goes from the asymptote to infinity. And my y-intercept was at 0, 1/2. Remember when we talked about the y-intercept, this one, it's going to give you the value of a. So a is 1/2. Okay, then also remember if we talk about where x is 1, that's going to come from, so I had 1, 1, and that 1 came from our a, 1/2 times b, 2. Okay, so now that we understand that, let's go back up to this note that we passed. If you're given the graph, so let's say instead of giving you the equation, I give you the graph. So let's just say, for example, if I covered up, let me see if I can get this to work. Oh, it's not going to cover it up. But let's just say that I covered up the equation, and instead I gave you this graph. So I gave you this. You could build the equation from that, because you know you can look here to find the a value, and you know that this number is going to be a times b. So you can plot, you know that a is on the x or on the y-axis, and then you know that whatever you have at +1, you're going to do a times b. So if you know the a value, then you can figure out what to multiply by to get to the b. So if I knew my a was 2, and I knew at 1 I end up at 6, well, 2 times what is 6? 3. So now I know that a is 2 and b is 3. So in the assignment you're about to do, you're going to have to look at the graphs to find the equations. Think of it in that way, okay?